question 6. Question 6 of 18, exercise 18E. Okay, a cuboid has a total surface area of 150 and a square base of x. Okay, so cuboid basically means cube, like this. So this is what a cuboid looks like. We got a square base of x, side length x, so the base is square. The height is going to be like this. Okay, so we're assuming the height's going to be different to the base. Okay, like the base and the length of the width. So I'm just going to call that h. We want to show that the total surface area is 150, and we want to show that the height is given by this equation. Okay, so this could be a very good sub question. Now, if you can't get the first answer, that's fine. You can still use the first what they've given you in parts B and C and D. Okay, I don't want you to feel like if you don't get it, then that's the end. You get no marks for the question. You can still continue the question even if you forget this part, can't get this part. So first step is I know the volume is given by x squared h because it's x times h, or length times width times height. Now the problem is I've got two variables. Okay, I need to change it to one variable. So I'm going to use the idea of surface area to get that other variable. So we know surface area is given by, well, I've got 6 surfaces. You know that this face plus that face plus that face, so the back face plus the side face plus the other face, would give you this total surface area. So total surface area we know is 150, which equals length times width plus, so xh, you got two of them. You got 2 x squares, and you got 2 xh again. Okay, so you should get, this should give me 4xh plus 2x squared equals 150. Okay, so this should be your equation. Now, I need to make h the subject because I want to get it in terms of x's only. So I can first of all divide both sides by 2. So you get 2xh plus x squared plus 75, and move the x squared to the other side, 75 minus x squared. 75 minus x squared. And then divide both sides by 2x. So 75 minus x squared over 2x. Okay. And guess what? We showed that h equals what we have here, which is great. Okay. Now we want to express the volume in terms of x only. Okay, so this is where we know volume is length times width times height. So volume equals x squared h. Now, because the base is the same, the length and width are x's, and obviously the height's h. So that's how I got that, and I sub in by h. So 75 minus x squared on 2x. Okay. Now you can cancel all the x's here, so you're left with v equals x 75 minus x squared over 2. Okay. Now I'm going to determine the maximum volume as x varies. So we've got our volume. To get the maximum, you let dv dx equal 0. So I'm just going to go find dv dx first. So type in the equation x times brackets. Now I always put a times there just in case it doesn't register. Fraction button. 75 minus x squared divided by 2. I want to differentiate that first. Okay, so this is to get dv dx. Let's see if we can simplify it. No, I can't simplify it. So it's -3 x squared minus 2500. -3 x squared dv dx. So you would show this working on your calculator. -3 25 minus x squared over 2. Okay. That's my dv dx, and x squared minus 2500. Okay, and you let dv dx equal 0 to get the maximum. You let derivative equal 0 to get the maximum. Solve it. So let it equal 0. Solve it. Interactive and solve. So it occurs when x equals -5 and 5. So it occurs when x equals -5 and 5. Obviously, we don't want that solution since x is greater than 0. Okay, we want positive values only. We're talking about x represents length measurement. You can't have negative lengths, okay? So x equals 5 for the answer. So what is the maximum volume? So we sub this back into the original to get the actual maximum volume. So I'm just going to get this, and given x equals 5, you get 1.5. So Vmax equal 125 centimeters cubed. Okay, so you've got to make sure you answer the question. So this part's good, but you need this final answer. Okay? And if the maximum volume um, of the square length of the cuboid is 4 centimeters, what is the maximum volume possible? Okay, so if it's 4 centimeters, what is the maximum volume possible? So what you do is, okay, if the maximum height, okay, so for part D is, if x equals 4, what is the maximum volume possible? So if x equals 4, you sub this back into the equation. X equals 4, the maximum volume possible is 118 centimeters cubed. Okay, so the last part is just subbing in x equals 4. You don't have to do calculus anything. It's just asking here for that. So hopefully that helps.